Okay, so I think we should start. We should not wait much for the people. They might be joining later, but attendance is very important. Okay, so guys, good evening, and I welcome you all to this 2 days wonderful workshop that is 6 to 8 hours of the learning. Okay, 6 to 8 hours of the learning on SPSS, data analysis using SPSS, the practical approach. So why it is a practical approach? Because we are going to learn everything hands-on, whatever we are learning, except some details which are very basics about biostatistics. We all will be learning together over the SPSS software. So that could be, there are multiple assignments, and I have already shared the sheet with you. Okay, I have already shared the sheet with you where you can work on with me and where you can learn the SPSS. You can learn the SPSS with me, and I'll teach you how to use the SPSS, how to use the things, how to take the test, how to run the test, which test to run where, what are the data types, and all everything will be, I'll be teaching you. Okay, so again, let's welcome you all and let's start. So guys, first let me tell you the instructions. Okay, a little instructions. So everyone have to attend this class with the laptop. Okay, because we need the laptop, and remember, this will not work on the Apple products. SPSS doesn't work in the tablets also. Apple iPad or the tablets, SPSS doesn't work in tablets or iPads or mobiles at all. It needs the laptop or maybe MacBook. Okay, it may work in the MacBook. It works in the MacBook and laptops only, because this is one of the big data analytical software. And I'll tell you, there are the free versions of the SPSS which are available for 30 days. Full-fledged SPSS for 30 days. I'll be telling you how to use the SPSS and how to download it, how to install it, and then we will practice on it. So today's class will be completely basics for next 2 hours. Completely basics, let me tell you guys, completely basics. Basics means I'll be telling you first about the data types, what is data types, how to collect the data, what are the test types, how to, put the test, how to run the test, which test to put where. Okay, and what is biostatistics? That is very important. And I believe for all B Farm, M Farm, research scholars, PharmDs, and even the other people who have joined here, it is very, very important. Okay, for the researchers, for the academicians who are joining, because they also need to do the research. This is one of the kind of need of the hour. Okay, this is one of the need of the hour for everyone here, right? So that's why we came up with this course, and this time we had the limited seats, and there are many people who have joined and who couldn't join because of some university exams are going on, but that's okay. Okay, but this course is going to be for 8 hours, almost 6 to 8 hours, as I told. But when we were just talking with my team and few of the students also, so this is very tough to teach or learn continuously only one subject for 4 to 5 hours or 6 hours. So that's why I thought to divide this course not only in 2 days but 4 days. As you must have seen the your schedule, this course, this entire workshop will go for 4 days. Okay, we will cover the entire SPSS for you. I mean, whatever is mentioned for in the 4 days. So today I'll take around 2 hours. Tomorrow, Dr. Siddesh will take about 2 hours. Day after tomorrow, Siddesh will take about 2 hours. And then day after, I will again, I mean, the Tuesday, I will only take 1 hour class, around 1 hour class on the sample size. Okay, how to detect the sample size and how to get the sample size, what's the importance of the sample size and all, right? I think you are very well aware of the schedule. So this is the schedule. Today I'm going to discuss introduction, types of data variable, how to choose study design, how to select the statistical test for research work, introduction to the SPSS, and measures of central tendency. I'm not going to take because Dr. Siddesh will be taking with the entire other part. Okay, so first 4 topics I'll be taking today. Okay, and then tomorrow tomorrow's class is morning 11 a.m. to 1:30 p.m. and then again Monday and Tuesday it will be from 6 p.m. Right, as tomorrow is Sunday, so we will keep it from morning 11 to 1:30, and this will be 100% hands-on practice. Okay, this will be 100% hands-on practice, and Dr. Siddesh will be practicing it on the uh, software that I am helping you to download today in today's class. Okay, so that is the schedule for all of you for this uh, workshop. So let's start. There are three modules for today what I'm going to complete. One is like SPSS software installation, then basics of biostatistics, and again basics of biostatistics part 2. So today, first let's start with the basics of biostatistics module 2, because SPSS comes later. Okay, SPSS comes later. When we understood the basics, then we can easily use the SPSS. But everyone has to download it today, so there is no problem tomorrow or in upcoming classes. And I have already shared the data set for today. You all will be going to work on the same database, and I'll be working on the same database. And for tomorrow, there will be different database what Dr. Siddesh will be sharing with you. Okay. So let's not wait. Let's start, guys. Let me share the screen and let me see module 2. I think this is the correct module. Yes, biostatistics part 2. Okay, that's the correct one, part 2. And everyone here, it is very, very important. You all have to be here and all have to be listen to it and work on it. Right. Yes. So let me start. Just give me a minute. Just give me a minute, guys. Yeah. So see, today we are starting with okay, my the problem. Yeah, yeah. So today is our day one, and we are starting this data analysis using SPSS practical approach. And today, I mean, first we will discuss about the basics of biostatistics, and then we'll go back to the module one, which is SPSS installation. And what is SPSS? That is very simple. So I'll tell you later that. Okay, and I'll tell you how to download it, how to use it, and all. Everything will be discussed there, right? So let's see. So first of all, statistical analysis. Okay. Uh, no, 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 no. Oh no. No, guys, I think this is the mistaken slides. These are not the slides exactly. One sec, let me check the other slides. Okay, let me come up with the correct slides. Give me a minute. Okay. Give me a minute, guys. I'll come up with the correct slides. Wait. Okay. Just one sec, guys. Okay, just one sec. I'm getting the correct slides, so we can start with that. This is somewhere what I was showing us. Like this is somewhere from middle of the presentation. Hmm. Yes. Okay. Yeah, I got it, guys. I got it. I mean, maybe the title is different, but I got the slides. Let me start. Okay. You will see the person who is hitting the head. Okay. Okay. Yes, guys. So this is what we are going to start. Okay. I hope it is visible to all of you. Statistics. Yes, guys. Just confirm if I am visible, audible, and the slides are visible full screen. Please confirm in the chat box, or you can open your mic. Okay. Great. Thank you. Thank you. Thank you very much, guys. So see, what is statistics first of all? Okay. What is statistics? See, statistics is nothing but wherever we have data. Okay, wherever we have data, we have data. Data means maybe from the research. Okay, maybe from the research, or from the company. Maybe company data is there, maybe the college data is there, maybe the university data is there. So we have the data. Data could be any type, numbers. Okay, data could be any types, numbers. So when we have numbers with us, we are clueless. Okay, when we have a lot of numbers, if I say you have the class of 10th standard. Okay, there are 100 people, there are 100 students in the 10th class, there are 100 students in the 10th class. So if I ask you, what is your what is the weight of your class, weight of your class, what you will tell? What is the weight of your class? Tell me. Weight means the weight and height wala weight. So what is the weight of your class? Can someone tell me what is the weight of your class if there are 100 students in one class? So the thing is, the logic behind it is, either you have to go, you have to ask everyone's number, then you will tell, combine everything. Okay. I mean, you don't know the things because you have everyone's, maybe you have the weight of everyone, right? In a list, you have the weight of 100 students, but what is the weight of the class? I'm not asking the sum of the 100 people's weight. I'm not asking the sum of the 100 students weight. What I'm asking is, what is the average weight of your class? What is the average weight of your class 10? So what you will do is, you will get the mean or mode or median central tendency. You will get something which the one number represents the entire class, only the one number which represents the entire class. So you will add all the hundreds and divide by the 100, right? That is called as like measuring the mean. So mean means the average. Okay, so you will get the average of the class and you will say, oh sir, average of the class is 53 kg, or maybe 57 kg, whatever. Okay, average of the class is 57 kg. If I ask, what is the age of your class, sir? What is the age of your class? So what you will do, you have age of everyone, but what you will do, okay, 100, you will just add all the 100 ages, divide by 100. So whatever the age comes, that will be the class age of the class. So statistics is nothing but collecting the entire data, and analyzing the numerical data. I mean, analyzing that data and getting the objectifying number, getting the number. Okay, number could be mean, mode, median, or maybe the p values, maybe the range, maybe the standard deviation, maybe the standard error of mean. I mean, there are many things, there are many variables, there are many statistical results what we need, either normal or non-normal. We need a lot of things in the statistics, right? According to objectives of our research. So statistics is collecting the data and analyzing it to get the numerical results. Okay, and how exactly the definition of statistic comes? Like, it is the collection of data, classification of data, tabulation of data, presentation of data, and analyzing it, and then interpreting the results, interpretation of the results, that is called. And this definition was given by Croxton and Corden. Okay, Croxton and Cordon. So let me tell you guys what exactly the statistics is. So statistics first is the science which deals with the data collection. First of all, this is the entire scenario. Okay, you won't believe, but this is the entire scenario, guys. This is the entire scenario of the research. How the research is being done. How the research is being done. So first you have the protocol, you got the approval. Now you have to start working on the research. What you will do? You will first of all go and collect the data. Okay, you will go and collect the data. Either that data is from society, community, hospital, or anywhere. Okay, or anywhere, or the company records, or the your company finance chart, anywhere. This data will be collected, and this data will be collected based on your based on the sample size, like what kind of sample size you need, what kind of number of the participants you need in the study. Maybe there are 150 employees in the company. You need the data of 150 employees. Okay, maybe when you are working in the patients in the hospitals, you need sample size, like the the number of participants which will be enough to do a research. Sample size is the number of the participants which is enough to do a research. That is called as sample size. Okay, so based on the sample size you will collect the data. And from where you will collect the data you will collect from the source. Okay, you will collect from the source. So source could be, as I told you, source could be community, society, or source could be the hospital. Okay, source could be the other data sets. Source could be the reference data sets. Any kind of source will be there. You will collect the source. You will collect the data from source. And then what? How you will be defining that? According to the study size, study design also, like what kind of study you are doing, cohort study, or you are doing some maybe you are doing cohort study, or you are doing some type of other studies, maybe the case control. Sorry, sir. Sorry, guys. I got a call from sir. Okay, so see, you collect the data from source, okay, according to the sample size and study design, right? The first thing, the first step of any research is collection, data collection. Okay, data collection, and then based on the data collection, you look at the data, you refine the data, and you check what kind of data it is. What kind of data it is, what type of data it is, what type of category of data it is. So there are two categories usually. One is quantitative, one is qualitative. Okay, one is quantitative, one is qualitative. I'm coming to that in the next slides. So we have to look into the data, because the data analysis, okay guys, let me tell you here only, the entire analysis of the data, entire software works only on the data type. Okay, if you know the data type perfectly, you will not stuck anywhere. You will not stuck anywhere. So you must be aware of the data type. Okay, I'll tell you. Then once you know the data type, then you go for the data entry in the spreadsheet. Okay, suppose you collected the data in paper format, and you now entering the data into spreadsheet. I mean the this Microsoft Excel, or maybe you can directly enter into the softwares like SPSS or other softwares. So you can do anything. Spreadsheet is usually Microsoft Excel. You are entering the physical data into the digital data. Okay, once your digital data is ready, you can directly import that to the SPSS. You can directly use that in the SPSS or any kind of software. Okay, in any kind of software, any kind of data software, whether this is SPSS, SAS, or G Power, or Prisma, or Lotus. There are different softwares, right? So you can directly import that data, import the spreadsheet into the software, and then you can run the analysis. Okay, you can run the analysis and you can get the descriptive analysis, hypothesis testing, and then based on that you can make the graphs or summary and tables. That is called as data representation after analysis. Okay, and once it is done, see, the why we have to represent the data, because see, we are giving this data to the layman people also. See, definitely, suppose I'm doing my PhD. Okay, suppose you are doing your, graduation. Okay, when I was doing my PhD, then that time I have collected the data, and that data, when we go to the conferences, right? When we go to the conferences, we don't know what type of people will come and what type of people will look at your data. Maybe there are students, there are nursing people, there are physiotherapy people, there are cardiology, there are clinicians, statisticians, multiple type of data, multiple type of people, various type of people will come to you, and they don't understand statistics. They don't understand numbers. Okay, so what they will look at is they will look at the figures, they will look at the tables. So easily understandable things they will go for. So that's why even after the spreadsheet, you have to analyze the data, and after analyzing, you have to represent that in the form of tables, graphs, flowcharts, figures. Okay, so anyone can easily understand. And then other than that, you have to write it in the text form also. Okay, you have to write it in the text form also. That is also very, very important, because someone who is not understanding even the charts, there are multiple types of chart, histograms, flow charts, there are histograms, bar charts, pie charts, okay, and scatter plots. There are multiple type of plots also, charts also. So if someone is not understanding, you have to define in the text, right? So that is called as summary tables, graphs, and descriptive type of things. Okay, once everything is done, you have to interpret it in the words. Okay, interpret it means like, okay, what exactly this is showing. Like, okay, if I say in the class, okay, if I say I'll come back to the class 10. Okay, you have 100 people's data and you have the 100 people's weight. You got the average also. Okay, you got the average also. So if I'm asking what is the different age of male and female in this class, right? So you will tell, I mean, suppose I'm asking about your class. What is the, describe your class 10. Okay, describe your class 10. So how will you describe? You have all the analytics, you have all the spreadsheet, you did the analytics, you represented the data, but interpretation, if I'm asking, please tell me how you are defining your class. So what you will tell? Okay, sir, my average age of the class is 15 years, average weight is 58 kg, and in my class there are 40% girls and 60% boys, or maybe whatever, vice versa. I mean, okay, so this is the description you are giving, this is you are interpreting based on the results. Okay, based on the results you are telling me that there are 40% of the female in the class and 60% are the male, right? So this interpretation will come after the analysis. This interpretation will come after the analysis. See, this is very basics for everyone. You all know this, what I'm teaching you, but it is very important to understand. Okay, so this is the statistics. This is the flow of statistics: data collection, then classification, then tabulation, and then analysis, representation, and interpretation of the results, right? Now, the thing is, if you look at this, this has described the pattern. See, this is just raw data and spreadsheet. Okay, this is just raw data and spreadsheet. So they have done the study in animals. There are 6 animals, and in the control and in the drug category. So this is the weight, this is the, sorry, dose of the drug, maybe. Okay, see, usually uterine weight content. Okay, uterine weight. So at the dose of 300 mg per kg, this is the uterine weight. At the dose of 600 mg per kg, this is the uterine weight, and at the dose of 1200 mg per kg, this is the dose, I mean, this is the uterine weight. So what is this? This is normal. This is just a spreadsheet. This is just the spreadsheet. This is just the Excel sheet. This is just the raw data. If I hide this, and if I hide this part, if I hide this part, can you tell me after this, if I ask you immediately, okay, can you tell me the difference between the mean, median, mode of this all three groups at 300, 600, and 1200 mg kg? How? how you will define it, how you do it. So you have to go for the analysis, and after analysis you come up with this. In control, uterine wet weight is 98 plus minus 3.14. In DES it is 221. In CO3 at the case group with the 300 mg per kg, it is 162, 185, 262. So now, again, now, if I ask you simple question, guys, which one is the highest uterine wet weight? Which one is the highest uterine wet weight? You are educated, you know. You will tell, sir, at the, in the case group with the 1200 mg per kg, this is the highest wet weight, 262.2 into, 262 point two, milligram. Okay. Then the second number is DES. DES is 221. The least weight is in the control group, 98 gram, 98 milligram. Right. Wet content is 98 mg only. Correct. Correct. It is correct. But if I ask the same thing, to you again by showing this, you don't have to even read, you don't have to even go through these six values. You will immediately say, oh, this kind of brown color is the highest one, and then this purple color is the second one. Simple. Immediately you will read brown color is case, control, sorry, case with 1200 mg per kg. So this is called as representation. This is called as perfect representation. Perfect representation of the data. Okay. Now, after the representation, types of data is very important. But before types of data, what is biostatistics? Nothing else. The application of statistics in biology. Okay. Application of statistics in biology is called as biostatistics. And biology, there are multiple domains, either that is medicine, dentistry, pharmacy, life science, agriculture, fisheries, marine science. It could be any biology. It could be genetics. It could be any biology. If we are using the statistics in the biology, that is called as biostatistics. That is called as biostatistics. Okay. And now see why exactly we need the analysis. First of all, we learned about the statistics. What is statistics? How it works? How it helps? Now, why exactly we need the statistical analysis? See, are these two different, truly different? Are these two animals truly different? Can someone tell me? Can someone answer? Open your mic or tell me, are these two animals different? Can you recognize these two animals? Guys,
Yes, sir.
yes, tell me.
They are different, sir.
They are different. What are these?
A tiger and a buffalo.
Tiger and the buffalo. Absolutely. Yes, tiger and the buffalo. Everyone can see one is tiger, one is buffalo. Right. One is tiger and one is buffalo. But after that, what? After that, what? This is visible. These things are visibly different. We can easily tell, and we can tell these things are easily recognizable. Right. Now I am telling, I'm asking in this group, like group one, average height is 5 feet. Okay. Average height is 5 feet. Okay. Can you tell me the average weight of these people? Can you tell me the average weight of these people? See, they all are looking fat. Literally, if I look at everyone, they're looking fat, right? And look at this average height, 6 feet. Can you tell me the weight of this group? Can you tell me the weight of this group, or can you tell me the weight of this group? Weight of this group and weight of this. Ajit, tell me simple question. Do you think there is a difference between weight between this group and this group?
Yes, sir.
Yes. Okay. Tell me why and how. Anyone can answer. Come on, there are 30 people. Please answer. Accept me, there are 30. Please answer.
By appearance, we can say, sir.
By appearances, you can say. Okay. By appearances, you can say there is a weight difference. Okay. Anyone else? See,
As they are different heights, so the weight will be different.
different heights, the weight will be different. Let me tell you. the weight of this group is exactly equal to the weight of this group. I mean, see, number of the people is same in this group and this group. Okay, number of the people, I'm just showing number of the people is same in this group and this group. And weight is completely equivalent. Okay, average weight is equal from this group to this group. How did we come to know? See, by appearances, we cannot say. We have to check it, and that's where we cannot differentiate. Listen, where we cannot differentiate the exact difference by appearances, we need statistics. Okay, see, so first of all, see, look at this. When it is difficult to distinguish the real differences from random variations, like between two or three groups or whatever, by visibility, in this case, we need statistics to make the strongest possible conclusion. See, by appearances, you said no weight is matched, right? The weight of both the groups are not matched. But when did you do that? The analysis, the statistics, weight of this group, average weight of this group, that is equal. So to make the strong possible conclusions, first of all, from limited number of data, we need statistical analysis. Okay. And when it is difficult to distinguish the
Suko,
real difference, yes, somebody is
Suko.
speaking. Guys, please put off your mics if not speaking.
I'm
Okay.
so sorry. I forgot I was on mute. I'm so sorry, Dr. Ajit.
No worries, Divas. Sure. Thank you. Okay. So this is like, if you are, I mean, it is difficult to distinguish. Okay, by the appearances, by the numbers. Then you have to go for the statistical analysis. And then to avoid the bias. See, if you are unsure, guys, if you are unsure about the statistical analysis, if you are unsure about the data, if you are unsure about the results, please do that. That's why the statistics is there. That's why we have the softwares. That's why we analyze the data to make the strongest possible, okay, strongest possible conclusions. Okay, so that's why we need statistics, right? Now you can see the best part of the presentation, best part of the today's class is here. Types of the data. Okay, types of the data. So guys, there are two types of data. Okay, there are two types of data. One is quantitative, that is how much is that. If I say that is completely numbers, that is completely numbers. Okay, you have to focus here. Quantitative data. Okay, quantitative data is like how much is there. 1 2 3 4 5 10 15 20 150 150.5 20.4 whatever. Okay, how much is there, we can measure it, we can count or measure it, we can either count or measure it. Quantitative means there is a number. Quantitative means there is the number. I mean, number is everywhere. See guys, first of all, remember this thing. SPSS is the numerical based software. Okay, SPSS is completely numerical based software. You need only numbers when you are analyzing. Okay, so I'll tell you why and how. You need only numbers. There you cannot go ahead with the text. You cannot go ahead with the text at all. This is not a textual based software. This is even the SAS or everything. These are not textual based software. These are all numerical based softwares, numerical based analytical softwares. Okay, so there are two types of data. One is quantitative. Quantitative means how much, the numbers. Okay, the numbers are also two types. One is continuous, one is discrete. What is continuous? Continuous means, like, as per my differentiation, there is only two things. First, remember guys, they are like measured. We can measure it. Okay, if we can measure it, that could be having at least, I mean, it would be or not, may not be. First of all, there is no specific limit. Okay, no limit. Okay, no limit, no specific limit. Second thing is there is decimal. Okay, there is decimal. When we are talking about continuous data, there is decimal in that and there is no limit. Now let me give you the example. Suppose age. Age could be, I mean, there is a huge difference between the range. There is a huge range. Third thing is huge range. Okay, huge range. I mean, the gap between the first, the lowest and the highest. Gap between the lowest number and the highest number is too much. Okay, gap between the lowest number and the highest number is too much. So that is called as range. Like suppose age. Age is matching completely all three. Okay, completely all three. First of all, no limit. Age could be 1 year also. Age could be 120 also. Right. So there is no specific limit in this. It could be 66 also. It could be 67 also. Right. It could be 31 also. So there is no range. I mean, there is no limit, specific limit. And then range is huge. Range could be 0 to 120, 150, anything. I mean, we don't have 150 years old people, but range is huge from 0 to 120, 115, 120. So we have right now with us, there are people who are aged 120 years. Right. So there is huge range. And the third thing is decimal. There are most probably the decimals. Age could be, yes, 12 and a half year, 13 and a half years, 65 and a half years. There are decimals. Okay. If you look at the height could be, the 20 centimeter also, or maybe 50, 40 centimeter also, and height could be 200 centimeter also. Huge range, no specific limits. Okay, no specific limits. And if you look at the height, there is 1.5 meter also, 1.4 meter also, 5 feet 6 inch also, 5 feet 3 inch also. Decimals are there. Okay, so that kind of data which is continuously having no range or maybe huge range, and decimal is having, and there is no specific limit, that kind of data is called as continuous data. Okay, so all like age, height, weight, blood pressure, HR, heart rate. I'm giving you these examples: age, height, weight, HR, and all. So the these type of data, I'm sorry, it's gone on mute. So these kind of data are called as numerical data. Numbers. Okay, all numbers. I mean, everything is numerical here, but it is numbers. How much? How much? This is quantitative. This is quantitative. Okay, this is quantitative type of data. Okay, this is quantitative type of data. But when we go to the another part of quantitative data, I mean, this is continuous. When we go to the other part, that is discrete. Discrete will not follow all these three things. Okay, discrete type of data. One second. Okay, so guys, I'm sorry, it was not showing properly. Oh no, that's not the, yeah, yes, we are here. We are here. So we were just talking about the data type. Okay, so continuous type of data, as I told you, it follows huge range, right? Huge range. Then there is decimal, right? And there is like no specific limit. Okay, no specific limit. right? So when we have all these three things, there is another type of quantitative data only, that is called as discrete data. So discrete data means it does not follow these three things. See, discrete data is like very less. Again, this is number also, quantitative only. We can say how much it is, okay? But again, there is a condition like numbers. There is no huge range. There is no decimal. There is no specific limit. Like what? Number of the children in family. There would be either one children, two children, four children, 10 children, 15 children, 20 children, but no huge range. Okay, range is limited. The range of the children here is limited. Number of the asthma attacks. Suppose we are talking about the clinical research, number of the asthma attacks in a month. Like, okay, 4 attacks, 5 attacks, 10 attacks, 15 attacks, maximum 30 attacks. Every day there is 1 attack, 2 attacks, 60 attacks, right? But that is limited. Okay. And number of cars in the family. Number of cars in the family. 1, 2, 3, 4, 5. Limited number. First of all, there is no huge range. There is no, there is a specific limit, no huge range, specific limit, and there is no decimal. You cannot count your children like, oh, I have 2.5 children. I have 1.5 children. There are 3.5 children, or I have 2.5 car, or maybe, I got 3.5 asthma attacks. Not at all possible. So in quantitative, there are two types of data. One is continuous, one is discrete, and that differentiate the factors which differentiate these are huge range, no specific limit, and the decimal. Okay, these are the different of data. Now my question for all of you is, because we are working on the same platform right now, I'm teaching you, give me another example of one continuous type of data other than age, height, weight, or whatever I told, blood pressure and heart rate. Tell me one or two examples of continuous type of data. Tell me one or two examples of discrete type of data, except whatever I told, guys. Yes, please tell me. Fast. Yes, people. Looking for your answers. Yes. Continuous cholesterol levels. Absolutely. Cholesterol level, GlyHB level, your NT-proBNP level, DROP-T level, your HB, hemoglobin, anything it could be. Okay, it could be any investigation. That could be any investigation which has the points, decimal, no range. Okay, in that category, no range. This tough to maintain, tough to count, or tough to there is no specific limit in that. Okay, and then give me another example of discrete data, guys. Discrete data. Yes, discrete data. Yes, discrete data. One example of discrete data. Rainbow colors. Wonderful. Rainbow colors. Yes, absolutely. Rainbow colors is the discrete data. Okay. Now, first data type is quantitative. Second data type is qualitative. Okay. Second data type is qualitative. Okay. What is qualitative data type? What is qualitative data type? Qualitative data type means the categories are there. There is no direct number. Okay, there is no direct number, but there are categories. We have categories, right? So categories are also two types. One is ordinal. If you look at this, one is ordinal. Okay, one is ordinal, one is nominal. So what is ordinal? As you can see by ordinal, there are ordered categories. We also call them ranked. Okay, ranked data. We also call them ranked data, either ordinal or ranked. It shows by the name. Ordinal means there is an order. There is a rank. There is a rank in the data set. There is a rank or there is an order in the data set. There is a hierarchy. There is a hierarchy. So there is the higher number and there is a lower. Okay, there is the categories. Categories are order in the order or in the rank, like from ascending order or descending order. These have the order. That's why the name is ordinal. Okay, like pain score. If you look at the pain score from 0 to 10, it is increasing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you look at the height category: short, medium height, tall. Short, medium height, tall. Grade of breast cancers: better, same, worse. Severity, any kind of severity if you look at, that is in the grades: mild, moderate, severe. Mild, moderate, severe. If I ask you BMI categories are ordinal categories. Okay, BMI categories are ordinal categories. How BMI categories are like underweight, normal, and underweight, then normal, then overweight, then obese, right? Underweight, normal, overweight, obese. So this is a rank. There is the rank. There is the order in the categories. Okay. Then another type is where no categories. There is no rank. There are the categories, but no rank. There are the categories, but there is no rank. Like religion, do we, we have Hindu, Muslim, Christian, Baudh, Parsi, we have all the religions, Sikhs. Can we tell which one is on number one, which one is in the least, which one is the last? We cannot tell which one is superior, which one is inferior. We cannot tell, we cannot recognize. There are categories based on the religion: Hindu, Muslim, Sikh, Isai, everyone, Christian and all, right? But there is no specific rank, there is no specific order. So these kind of categories are called as nominal categories. Like gender, male and female, can you tell which one is rank 1, which one is rank 2? No one can tell that which one is rank 1 and rank 2, right? Blood groups: AB, A, B, AB, O. So who will tell that which group is the superior or rank 1 and which group is rank 4 or rank 2, rank 3? There is no specific ranks, right? There is no specific ranks. So that's kind of categories are called as nominal categories. So categories are two types: categorical data or qualitative data are two types. One is ordinal, one is nominal. Okay, one is ordinal, one is nominal. And then there is another type of data called dichotomous data. There's another type of data that is called dichotomous data. Dichotomous, there are only two answers. There are categories, but only two categories. Okay, there are categories, but only two categories. And those two categories are also not in order. Remember, why dichotomous data or binary data is like how we go for it. That is not in the specific order. These binary, there are only two. That's why we are calling them binary or dichotomous, because only two only two categories are there. Only two categories are there, right? So this comes under the nominal. So two categories are like yes and no. Yes and no. You cannot say yes is first or no is later, no is rank 1 or yes is rank 2. Not at all. You don't say. You cannot tell. Male or female, again, there are only two categories, no rank. Vegetarian, non-vegetarian. We don't know, right? Which is rank 1, which is rank 2. There is no ranks. Alive or dead. Hospitalized, non-hospitalized. There is no rank. Right. So there are some categories where there are only two categories, but these two categories are also not in rank or order. Right, no rank or order, so we call them dichotomous or binary type of data. Okay, so understood. One is quantitative described in two types. One is what? In quantitative types of data, discrete and continuous. In qualitative, ordinal and nominal. In nominal, there is binary also. Okay, these are the major types of data. When we work in the SPSS, we work only on the discrete, qualitative, and mostly the continuous type of data. Now I have the exercise for you. Okay, now I have the exercise for you. You have to tell me the data type. Let me stop sharing this and let me share my Excel sheet with you, and you have to tell me what are that data type. Okay, what are that data type? So guys, ready with your answer? Ready with your answer to write or to tell me? Okay, tell me what type of data is duration. What type of data is duration? Yes guys, fastest finger. We are playing fastest finger exercise for you. We are playing fastest finger. What type of data it is? Duration. Continuous. Duration continuous. Okay, continuous. Duration is continuous because we have no range. It might be 1 month also, it might be 2 months also, it might be hospitalization could be for 45 days, 90 days, 3 months, 6 months. In psychiatric wards, there are people who are staying in the hospital for 2 years. So, right, duration could be any number. Age, fast, age, age, guys, fast. Age is discrete. Oh, Suhana, no. Age is not at all discrete. Age is continuous. Age is continuous. I have written the points also, decimals also. How can you say that age is continuous? Age is discrete. Okay. Next, tell me the gender. Gender. Fast. Gender. Binary. Absolutely. Devas. Gender is binary. Okay. Gender is binary. Yes, absolutely. Gender is binary. Okay. What is BMI? Tell me BMI, guys. BMI. Tell me BMI. Oh, BMI, people are writing ordinal. Ayyo, BMI. Look at the numbers here. Come on. I told BMI category there. Okay. If I tell you hypertension categories like, okay, grade 1 hypertension, grade 2 hypertension, grade 3 hypertension, will it be continuous or ordinal? Come on. If I'm telling categorical data, that is category. Blood pressure. Listen. Oh, don't spoil. See, blood pressure is continuous. Hypertension is hypertension categories. Hypertension is categorical, ordinal. Okay, hypertension is ordinal. BMI is continuous. BMI categories are ordinal. Okay, you have to think of many things. You have to think of many things. BMI categories is categorical data. Okay, ordinal. But BMI here is continuous. You can see the point, decimal. That's why you're getting confused, right? Okay, now the E, column E, SBP. Systolic blood pressure is what? Systolic blood pressure is what? Guys, systolic blood pressure. Yes, tell me the systolic blood pressure fast. Right. Systolic blood pressure is which type of data? Systolic blood pressure. Fast, guys. Yes, guys. Yes, guys. Continuous. Yes, continuous. Absolutely continuous. Okay. Yes, guys. Yes, continuous. And then next is hypertensive. Next, hypertensive. What is hypertension? 0, 1. What is hypertension? 0, 1. Yes. Ordinal. Okay. Are you sure?
Sir, dichotomous.
It is dichotomous. Absolutely. It is dichotomous. See here, if you look at the data, first read the data. That's why I'm telling. Hypertension is nominal here, 0 and 1 only. If the hypertension is there or not, yes or no. 0 is no, 1 is yes. You have to check. You have to be very careful when you are selecting the data. When you are talking about the data, you have to be very smart. You have to be selecting the data with very carefully. You have to select the data very carefully. Okay. Hypertension here is binary. If I talk hypertension categories, if you see 1, 2, 3, 4 or 4, 3, 1, 2 numbers, multiple numbers, then you can tell it is categorical. Okay. But right now it is dichotomous. It is just binary. Hypertension is there or not. Okay. Now look at this HbA1c and sodium. Tell me what kind of data it is. HbA1c and sodium. HbA1c is what type of data, guys? Tell me. HbA1c is what type of data? Continuous. Okay, so Hana is telling continuous. We'll agree continuous. What is sodium? Sodium also continuous. Okay. Statins. Statins. What do you think statin is? What do you think statin is? Ordinal. Oops. Binary. Binary. If the patient has taken statins or not. If the patient has taken statins or not. Yes or no. Only 1 and 2 is there. So that is nominal. Okay, binary or nominal. I mean, same thing, nominal. Okay, now the tricky question has come here. Antiplatelets. What type of data is antiplatelets? Please tell me. Okay, I'll describe. Don't stuck in the number. 1 is aspirin, 2 is clopidogrel, 3 is ticagrelor. Okay, 3 is ticagrelor. So which drug was given in antiplatelets? So tell me, now tell me, antiplatelet, there are 3 drugs. One is aspirin. I mean, one number is for aspirin, 2 is for clopidogrel, 3 is for ticagrelor. Tell me what type of data it is. Or you discrete, who is writing discrete or binary, guys? Come on, man. There are 3 numbers. How it can be binary? Oh, ordinal. Ordinal. Aspirin. Tell me in aspirin, clopidogrel, and ticagrelor, which is number 1, which is number 2, which is number 3. Not here in the Excel sheet. Rank wise. Tell me the rank wise. Do you think aspirin, clopidogrel, and ticagrelor are in rank? Oh, come on, no. This is a nominal type of data. I am describing you. Antiplatelet, there are 3 drugs. Drugs are not in rank at all. There is no order. There are 3 drugs, right? And it is not binary. And when I'm talking 3 drugs, different names, that is not discrete or that is not at all continuous. So that is nominal type of data. That is nominal type of data. Now the column number K. Column number K. Okay, column number K. That is CAG, coronary angiogram report. Let me describe, then only answer. Okay, let me describe. SVD, DVD, TVD. There are 3 terms. Single vessel disease where only one vessel was blocked. Say DVD is double vessel disease where 2 vessels were blocked. TVD is triple vessel disease where 3 vessels were blocked. Okay. Now tell me what is the type of data this is. Single vessel disease, double vessel disease, triple vessel disease. What type of data is this? Angiogram report shows in some patient it was single vessel disease, in some patient it was double vessel disease, in some patient it was triple vessel disease. So now tell me which type of data this is. Okay, tell me guys. Nominal. Ayyo guys, ayyo. Ordinal, definitely. When there is a rank, there is only one vessel, 2 vessel, 3 vessel. Ordinal. Definitely ordinal. See, you stuck, right? Now you stuck between antiplatelet part and CAG part. Okay, antiplatelet part and CAG part. So what's the difference here? See, antiplatelets means there are 3 drugs. I'm describing you. I'm not making you confused here. Okay, I don't want you to be confused here. See, antiplatelet, there are 3 drugs. There are like 3 reasons. Antiplatelet drugs, there are 3 reasons. One is aspirin, one is clopidogrel, one is ticagrelor. There are 3 different religions. No rank at all. There are 3 different drugs. In drugs, you cannot define which one is number 1, which one is number 2, which one is number 3. All have different distinguished characteristics. Distinguished characteristics. Understand that? If there are distinguished characteristics, they cannot be in the rank. So that's why antiplatelet drugs are not ordinal, nominal. Okay. If I talk about CAG report, there are also 3 variables. One is single vessel disease, one is double vessel disease, one is triple vessel disease. Definitely there is rank. These are also category. See, antiplatelet drugs are also category. There are 3 categories. And in CAG report also there are categories, 3 categories, right? 3 categories. But there is a rank. There is the order. 1 vessel involved, 2 vessel involved, 3 vessel involved. Understand? There is a rank. There is an order. Increasing, right? increasing, that is increasing. Descending order, ascending order, I told you, right? There is an order, so that is ordinal. Okay, leave it. That's why I am coming up with this practice chart so you can understand. I can come teach you and go, but practice is very important for all of you. Okay, second thing is, now the L, go to the column L. There is PTCA route. PTCA route means there is the treatment, we put the stents to the patient, and there is a route. One is RRA, that is called radial route. Okay, radial route. I mean, we put the stent from here, radial part. F is femoral route. We put the stent through the groin part. So there are two types of variables. One is RRA, one is RFA. What is this? Binary. Perfect. They was perfect. Dichotomous binary. No rank. No rank. Absolutely. Different characteristics. Binary, dichotomous. Fantastic, guys. Amazing. Binary type of data. Now, tell me diabetes. Diabetes. What type of data is diabetes? What type of data is diabetes? Binary. Amazing. Hyperlipidemia. Hyperlipidemia, same binary, one or two. This is if the patient is having diabetes or not having the diabetes, right? So hyperlipidemia is also patient is having hyperlipidemia or not. Done. Okay, guys, thank you. So you have most of you have passed in the exam. Okay, most of you have passed in the exams. You have learned what exactly is going on. Okay, now we'll go to the next part. Okay, data types we have done. Now the second part of this comes is data interconversion. Data interconversion. As I told, see, very first example I'll give you. You have seen the blood pressure, right? Blood pressure is from somewhere, blood pressure could be 60 mm Hg, blood pressure could be 160 mm Hg, right? I'm talking about one blood pressure. Will you take one? Systolic blood pressure you take. It could be 90 mm Hg also. Systolic also could be 90 mm Hg in hypertension. It could be 220 also in hypertension. That is continuous data. That is continuous type of data. Maybe there is no decimal, but there is no specific range. There is huge range. There is no specific range, right? So that is continuous type of data. High blood pressure, I'm talking about blood pressure. Then if I ask you kindly, I mean, there are the blood pressure for 100 people. There is a blood pressure readings for 100 people. If I tell you, please describe these 100 patients, please tell me, like, who has the less than 120 mmHg blood pressure, who has 120 to 140 mmHg blood pressure, who has 140 to 160 mmHg blood pressure, and who has more than 160 mmHg blood pressure. You will describe all 100. You will check the blood pressure, you will divide, and this is rank 1, this is rank 2, this is rank 3, this is rank 4. There is rank. This is like normal, sorry, this is like hypotension, this is like normal blood pressure, this is like hypertension category 1, this is like hypertension category 2, and more than 180 is hypertension category 3 or hypertensive emergency, right? So there are categories, of the data, right? So see, this is called interconversion. Blood pressure is only converted into the the continuous data is only converted into the categorical data, ranked data, right? Similarly, BMI, if you look at the BMI is continuous data, but you can convert BMI into categorical data. So see, look at this. Only continuous variables can be converted into nominal or ordinal by using cutoff values. Cutoff values like less than 120, 120 to 140, 40 to 160, 160 mmHg. So this is like interconversion of data. Blood pressure is example, height is example, right? But guys, remember, it cannot be reversed at all. You cannot convert if data is nominal, you cannot convert, or if the data is ordinal, you cannot convert it into the continuous. This is only one way suit up. Okay, this is only the one way path. You can convert only continuous data into different types of data, but not the ordinal data into continuous state. I'll practice it with you. Okay, I'll practice it with you, but after these after these PPTs. I mean, there are a few more, introductory PPTs. Okay, so now interconversion. Then after interconversion, there is statistical analysis. There are two types of statistical analysis. One is descriptive analysis. One is inferential analysis. Now, what is the difference between descriptive and what is inferential? See, it is simple. Descriptive means basic analysis, and inferential means the high-end analysis. High-end statistics is needed. High-end statistics means like survival analysis, Kaplan-Meier, regression, or those things, where we need specific differences. Specific differences, like we need p-value, significance. Wherever we need significance, that comes under the inferential analysis, where we just need numbers, percentage, range, mean, mode, median. Wherever we need only central tendency, that is called as descriptive analysis. Only description. Give you an example. Suppose, again, I'll come back to the 10th class. You have the class 10, and in that class 10, you have people, right? You have people. And if I ask you, describe your class, again, you will tell what's the age, what's the average age, what's the average age of female, what's the number of female, what's the number of male, what's the average age of female, male, everything. But if I ask you, is there any specific or significant difference between the age of male and female? How will you get it? You will get it by C. Maybe the age of, the weight. Suppose let's not go to the age. Age will be almost, I'm sorry guys, age will be almost similar, 15 or 16 years. But if I talk about weight of females and males, and if I ask you, is there any significance different between, the weight of male and female? What you will tell? Oh, sir, okay. The female's average weight is 43.5 kg and male weight is 58.6 kg. There is a huge difference. There is a difference of 45 and 58. There is a difference of 13 kg. This is a significant difference. Hey, who told this is significant difference? You cannot tell me that 13 kg is a significant difference just by subtracting the 58 and 45. Not at all. You have to check it by the statistics. You have to use the mathematical formulas and tell me if there is any p-value which is significant less than 0.05. If this is valid, then I'll say, okay, your male and female weight is different. Otherwise, there is no difference. I'll not say this is different or not. You have to go for the p-value. So that type of high-end analysis is known as inferential analysis. Statistical analysis is two types. One is descriptive, simple analysis, basics, and one is inferential. Okay, one question is here, sir, does standard deviation variance come under descriptive or inferential? No, it is coming under descriptive only. P-value, when I'm talking about where you go for the correlation, where you go for the correlation, where you go for the regression, where you go for the association between the variables, then we need inferential analysis, because that will be proved by the p-value only. But mean, mode, median, standard deviation, SEM, or these all things come under the descriptive analysis. Okay, these all comes under the descriptive analysis. These all will not go to the inferential analysis at all. These are just the descriptive analysis. Okay, so let me tell you these fast descriptive statistics, how to describe the data. So first of all, there is measures of central tendency, like and then frequency and percentage, measures of dispersion and variation. So let me tell you here only basics. What is central tendency? Central tendency is, suppose there are 100 people. There are 100 people in the class, right? I'm asking, just describe your class in one line. You will tell, okay, describe the weight of your class in one line, or describe your class in one line. Describe the result of your class in one line. You'll tell, okay, so my class has passed with 70% marks or distinction marks. Simple, done. Simple, done. Okay, you have described your class result in one line. My class has passed with the distinction marks. How did you tell the distinction marks? 1%, I saw the student number 67, roll number 67 got only 35 marks, and student number roll number 87 got only 42 marks. How can you say that your entire class is distinction? How can you say that the entire class is distinction, guys? Can someone tell me? Tell me, guys. I put all the
Mean
things in
of all the students' marks.
yes.
So if it's in that range, then you can say it is true, right, sir?
Yes, see, exactly. Someone else wants to put some more light on this? Anyone? When I know the roll number 67 and roll number 87 got only 35 and 42 marks, how can you say that their entire class is distinction passed? Are simple, guys, simple. There is something called average. Average marks. Your entire class average mark is 70%. Whether someone got 89, I mean 98% or 35%, doesn't matter. When you are calculating, when you are adding all the 100 values, and dividing by the 100, you will get the mean or maybe mode or median. So this one thing, this one term, this one value out of 100, that is the average, that is called as central tendency. Central tendency, the entire data, entire values, all the values are lying around only this value. Okay, all the values are lying around this value, and this value is called as central tendency. Okay, central tendency. So this central tendency could be, there are multiple central tendency, but major are mean, mode, median. There are three types of central tendencies. Percentage and frequency. Simple, percentage and frequency you know. Like, okay, there are 100 students in the class, 35 students are 35 students are female. Guys, tell me, what is the frequency, what is the percentage? Simple. Tell me the frequency and percentage. Come on, fast. Guys, don't tell me you cannot tell this answer. Third standard student can tell me this answer. Okay. There are 100 students in the class. In the class, there are 35 females. So what is the frequency and what is the percentage of the females in the class? 35% females, and frequency is what? Number 35 only, yeah. Simple. Number is 35. So frequency is 35 and percentage is 35. Simple, out of 100. Okay, now second question. Second question on your everyone's intelligence. I'm sorry, guys. There are 60 people in one, suppose in the class only, yeah. Let's take class. Okay. Out of 60, 45 got pass in exam. 45 are pass in exam. Only 45. What is the frequency? What is the percentage? Tell me. What is the frequency? What is the percentage? Fast, fast. What is the frequency? 45. Simple number. Number is 45. Percentage is 45. I mean, percentage is 75. 75%. Okay, percentage is 75 and frequency is 45. Okay, simple data you have to understand. Okay, simple data you have to understand. Now, if I tell you one more thing, that there is one more thing. Okay, there is one more thing called measures of dispersion and variation. What? Suppose there are two classes. I mean, there is only 10th standard. I'll talk about 10th standard today. But there is section A, section B, section C. Okay, guys, section A, section B, section C. Now, If I come to the 10th class, section A, B, and C, if I ask you, you are the class teacher. When you are the principal, not class teacher, sort of. You are the principal, okay, of this class, of this college. If I ask you, what is the average age? What is, sorry, average weight only I'll take. Average weight of your class 10, all sections. Guys, listen to me carefully and tell me. There are 3 sections in the 10th class, A, B, and C. If I am asking the average weight, you told average weight of A is 67, B is 67, C is 67. Wow. Is it possible? Is it possible? The average weight is same for all 3 sections. Is it possible, guys? Yes or no? Right? This class is very interesting, literally. If you ask me, it is very interesting. Okay. Is it possible? Yes, absolutely possible. Possible. Yes, possible. Not probably, Divas. It is possible. It is absolutely possible. Okay. All these 3 means or average weight could be similar. But where is the catch? Where is the catch? Do you think, now again, my question is, next question in this scenario, do you think all the students in section A, section B are on section C are matched weight? Matched weight means roll number 1 of all the 3 sections are similar weight. Roll number 2, roll number 187, all are similar weight. In the section A, B, and C, roll number 1 is similar weight, roll number 2 is similar weight, then the average weight is similar. Do you think is it possible? No, 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 yes. So there is a difference in each individual. Okay, there is a difference in each individual, guys. There is a difference in each individual, and that is called as measures of variation. There is a variation. Maybe all the students, all 300 students, 100 in A, 100 in B, 100 in 3, 100 in C, all 3 students are totally different in weight. All 300 are different in weight. Chai that is 100 gram only, but all 300 are different in weight. But the average of 3 sections, all 3 sections are same. It is same, similar, 67 kg. Then how to find out the difference? If the average is same, then how to find out that difference? The difference can be find out by, the difference can be find out by the variation measures of dispersion, like standard deviation. Sometimes standard deviation is also same for everyone. Then you go to standard error of mean. Then you go to coefficient deficiency, correlation coefficient. There are multiple things to check that difference. Check that micro level difference. Let's see. I'll show you. Okay. Mean, mode, median, like the data is most observed around the 1 point. That 1 point is called a central tendency, and those are mean, median, mode, as I told you. So it should be in the middle of the, almost somewhere middle of the values. Okay, middle values. So use of central tendency, as I told you, it will give you a single value to describe the entire group. It will facilitate the comparisons. As I told you, section A, B, C, male versus female, or group A versus group B, or maybe case versus control, anywhere. Okay. And it will compound the things. It will be used, central tendency will be used to compound the SD, standard deviation, confidence interval, and all. Right. Let's see. Population mean. This is the formula of mean. Whatever the number, you just add all the numbers, and divide it by the number only. Like if there are 100 students, add all the 100 students values, either it is weight, age, or whatever we are asking, and divide by 100. Simple, you will get the mean of the class or mean. So see, it is calculated by the adding up the individual observations and dividing by the number of the observations. Okay, don't go to the formula. If you want to remember. But simple formula is add up all the individual observations and divide by the number of observations. Simple. What are the merits? It is used only for the continuous type of data. Bad. Mean can be used only in the continuous type of data. Even mode and mean usually is used in the continuous type of data only. Okay, guys. And the demerits are when we have continuous type of data. Okay, when we have continuous type of data, suppose I'll go back to the 100 people only, 100 students only, class of 100, class 10th of 100 students. I want to know the mean weight only. Okay, mean weight only today, right? You have no data with you. You are telling, sir, we have to check the weight of individuals, then I'll tell you the mean. I'll tell, okay, go and check. When you go to the class, there are only 92 people. 8 people are absent today. 8 students are absent today. What you will do? You don't know the age. You don't know the weight of those 8 people. Those 8 people, right? So you will count the weight of those, these 92. What you will do to show me? You will divide it by 100. You will divide it by the 100 only. And you don't know, the difference will be huge. The mean will be totally tempered. Mean will be totally tempered. So it is not at all suitable for the missing data. If your data is missing, then you should not go for the mean, because you don't know that missing value, whatever it is. And see, if I am checking the mean of 92, then I must be adding all the 92 values and divide it by the 92 only, not 100. But when you are doing it, when you're doing in the research, you have to check total number, and you have to divide it by the total number only. So whenever data is missing, you cannot use the mean. And then extreme observations, not, it is very much affected by the extreme variation, extreme observations, extreme observations. It is not suitable in the extreme observations also. Not suitable in the extreme observations also. Can someone tell me, guys, what does it mean by extreme observations? Tell someone, what do you mean by extreme observations? Yes. Can someone give me the example of extreme observations? Or I'll give you another name of the extreme observations. We call them outliers. Outliers. What is the meaning
The
of
extreme observation would be like the measure of distance, na? It
measure
can
of
be
distance?
1 meter also, it can be in light years also.
Extremes of the data given. Okay, kind of, okay, yes. Let me come back to the class. Okay, there are 100 people. Oh, so sorry. Yeah, there are 100 people. Sorry, what's happening with the pen? There are 100 students, right? There are 100 students. Now my question is, what is the average age? Not go for the 100 students. Let's check with the 10 students. You will understand easily. There are 10 students in the class. In the 10th class, only 10 students. Okay, in 10 students, 8 are learning normally, like they are kids, they started just now and they are learning from now only. Okay, my question here is, or let me put you the full scenario first. Let me put you the full scenario first. So in those 10, 8 are normal kids who has started studying from the age of 5 or 4 or 6 maybe, right? So let me write, one is 16 years, one is 15 years, one is 14 years, one is 15 years, one is 16 years, one is 14 years, 15 years, 17 years. This is the 8 people. These are the 8 students. But in this 10th class, there are 2 more students, and those 2 more students are whom? See, they wanted to study, but because of the poor family status, because of the their conditions that time, they couldn't complete the study, and they have joined now in the later age of 48, and another one is 36. Okay, one is 48, one is 36. And if I ask you, what is the mean age of this group, mean age of this class? So if you look at these 8, these are normal values. And the average of these normal values will be coming somewhere around 15 or 16 only. Okay. And ideally, guys, ideally, the age of the 10th class, average age of the 10th class must be somewhere 15 or 16 only, because government says the student has to start, I mean the kid has to start studying at the age of 5. So by he's in 10th, he or she is in 10th class, she will be or he will be 15 years of age, right? But if you look at this, just add these things and divide by 10, this will be going somewhere 22. If I now ask you, tell me the age of your class, you will say, sir, the age of my class is 22 years. I'll be bloody surprised. Oh my God, your 10th class is 22 years old. Really? Why it is 22 years old? How it is 22 years old? I mean, I'll be surprised because I'm considering the entire class. But this is just, see, this is influenced by only these two people. This the entire mean age is influenced or affected by these two values. These two values are known as extreme values. See, average age is 15, normal 15. This is the age of 3 students. This is the age of more than, I mean, almost 3 students. Okay. So here, this, if the mean is 15, we have to consider, then this entire age is not for the 8 people. 8 plus 6, 14 students. And we are just dividing by the 10, right? So that's how I'm telling you, the mean are affected by the extreme observations. And these extreme observations are not just the high numbers, it could be less numbers also. It could be less numbers also. Like suppose the group of girls, I'm checking their athletes, or maybe in the class group of girls, and I'm checking the weight. So the normal weight is, like everyone has the weight somewhere around 45 to 50. But there are 3 malnourished girls whose weight is 20 kg, 23 kg, 28 kg, or 31 kg. Okay, this is extremely low. This is extremely lower than the normal, and this will impact the mean. Like this is impacting the mean. So you cannot go with these extreme values. So these are the extreme values, and mean is not a suitable central tendency to consider in case of normal values. I mean, in case of extreme values. And when data is missing, and when, as I told you, this is only for the what type of data? Continuous type of data. This is not for the ordinal or ranked type of data. So example, this is the mean example, you can count. Now median. Median is again the central tendency. I mean central tendency, central value of all the observations. And when mean is not suitable, median is perfectly suitable. Okay. Again, I'll come back. I asked the weight of 100 people, but there are 92 people only, 92 students only in the class. So median is not like first adding all the 92 dividing by 100. No, it is like I will take the weight of everyone. I will consider all the weights, and I will keep them in the ascending order, arranging them in the ascending order like lowest to highest. Okay, and then the middle value will be my median. Middle value will be my median. So how to check which is the middle value? Suppose there are two formulas. One is for odd numbers. If the total number is odd, if there are like 97 values, there are 97 students, then the simple formula is 97 plus 1 divided by 2. So 98 by 2 is equal to 40. How much it is? 49. 49. So 49th value in the row is your median. Okay, 49th row in the volume, in the, this is median. So it is easy. See, if there were like 10 students, and 10 students, when we are keeping them in ascending order, those 48 and 36 will go later, and your median will be somewhere 15 or 16 only. Okay, 15 or 16 only. So your median fulfills the demand which mean cannot, which mean cannot. And if you have extreme values or outliers, you use median than the mean. Okay, so now I told you about the mode, I mean odd numbers. If the number is 100, then how can you do that? How the observation will be counted? No, in that case, there is another formula. Okay, in that case, there is another formula, and even numbers, that is like, see, find the middle two values and average them. So in 100, what are the middle two values? Like 51 plus 52 and divide by 2. Find middle two values and average them. Like, see, there are six values: 177, 117, 120, 123, 125, 127, 127, 125, 125 divided by 2, 144. Simple. This is your median. Okay. Always median will be normal. If mean is not normal, median will be working. So merits not affected by the extreme values, and it is dealing with the ordinal data also, and it can compute when the data is missing also. So wherever the data is missing or something, that can be used. Okay. Now the thing is, like as I told you about the extreme valuations, extreme data and all, there is three things. There is one thing called skew. Okay, skew, data skewness. Data skewness. Okay, skewness is what? Usually when your data is perfectly distributed, when your data is perfectly distributed means there is no outliers, there is no extreme values. Okay, there are no outliers, there are no extreme values, so that data is normally distributed, and this is helpful in finding entire thing, finding the, like, which mean or mode or median we have to choose, which central tendency we have to go for. Okay, which central tendency we have to go for. So in that case, what you will do is you will find out the skewness. Okay, skewness is being done by the help of Leibniz test. Okay, that I'll come later, or Dr. Fadesh will tell you about the Leibniz test. So what is data skewness? See, if the data is perfectly normally distributed, then your mean, mode and median will be similar, or normal, I mean near similar. Okay, if your data is normally distributed means there is no outlier, there is no extreme values. Suppose in the class it will be maybe 15, 14, 15 only, everything will be normal, everything will be similar, there is no skew, the data is distributed normally. But if 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 the data is skewed negative, okay, that means there are outliers but with less values. Okay, outlier with less values, so those are decreasing the mean, but mean, I mean mode and median will be higher than mean. Okay, higher than mean. There are outliers but in the negative direction, in the negative direction, and in the positively skewed there are outliers but in the positive direction, so mean will be higher and mode and median will be less. As I told you in the class 10, I mean there are 10 people, one is 48, 46, then this is the positive direction. And if I told, if I've given you the example of the malnourished girls, that is the example of negative direction, negative skewness. Okay, so the data, if it is normally skewed, then there are a lot of things, okay, to do, and data must be, and the tests, let me tell you guys, tests, okay, all the tests and statistics are being depending, I mean are depending on the skewness only. Okay, mode is like most frequently occurred value, most frequently occurred value. Suppose the class there are like 15, 14, 13, I mean 14, 15, 15, 16. What is the most occurred number? 15. 15 is your mode. Simple. It is not affected by the outliers, it is not affected by the numbers, it is not affected by anything. It is just the mode, it is just the most frequently occurring value in all the observations. Okay, you can see here number of children per family, 1 1 1 1 1 1. So the repetition of the observation is called as mode. Okay, and this is being used in categorical or discrete data also, and this is being used everywhere, but there are some demerits. Okay, there are some demerits of that, but mode can be used everywhere, but we don't use mode everywhere because it miss the fidge, miss the actual difference. Okay, so that's why we go for the mean, not mode or median. But wherever the mean is not useful, we go for mode and median, I mean mode and median. Okay, now frequency and percentage, as I told you, male 32, 64% out of 100. Sorry, out of 50. Okay, A group out of 55 is 10%, 10 is 20%. So this you know all. Okay, measures of variation or dispersion. right? Measures of variation or dispersion is standard deviation, coefficient of variation, standard error of mean, range, and interquartile. Let me tell you by brief. See, as I've given you the example there, see, there are two groups of PharmD students, two sections of PharmD students, 10 students in each group. You can see all the students are different. 5.4 versus 5.6, 5.8 versus 5, 4.8 versus 5.7, 5.9 versus 5.5, 5.2 versus 4.9. But if you look at this, mean is similar, mode is similar, median is similar. And if you look at down, even the now the SD is different. SD, standard deviation, is different. So that is called as dispersion value or deviation value. Okay, deviation value, variance value, right? So standard deviation is defining the difference between the groups. Maybe the mean, mode, median are similar for two, but there is the difference between individuals. There is a difference between individuals. Okay, that is called as variance. Okay, so now let's come to this one by one. Standard deviation. So standard deviation is nothing but the deviation in the individual measurements around the mean, around the central tendency. There is a difference. Okay, maybe the mean is same, but there is a difference between the individual variations. How to check it? So it can be checked by the variance. Variance is s square. S is mean here. So S is SD here. Okay, so SD, standard deviation, is equal to under root x minus x bar divided by n minus 1. So x is the value and x bar is the I'll tell you log of value, and n minus 1 is the total number minus 1, number of the data minus 1. How to calculate it is a very simple, SD. If you are calculating by yourself, it's very simple. I'll tell you. See, look at this. There are seven values. Okay, so x is what and x bar is what? X is the value and x bar is mean. So you need mean to check the standard deviation. You always need the mean to check the standard deviation. Okay, suppose there are all mean of this is 8. Okay, 57 by 56 by 7 numbers, so mean of the entire values came 8. Okay, now what is x minus x bar? 8 minus 8, 5 minus 8, like value minus mean. Okay, so 8 minus 8 is 0, 5 minus 8 is minus 3, 4 minus 8 is minus 4. All values have come here. Okay, now square it. X minus x bar square is 0 square 0, 3 minus 3 into minus 3, 9, minus 4 into minus 4, 16, 4 into 4, 16, 7 into 67, 49, 3 into 3, 9, 1 into 1, 9. The x minus x bar ka epsilon is 100. The total of these values is 100. What is SD? 100 divided by 7 minus 1. 7 is n, frequency, right? Frequency is 7 here. So 100 divided by 7 minus n, 7 minus 1, 6. So 100 divided by 6 is 4.08. SD here is 4.08. Okay, simple. SD here is 4.08. Okay, similarly you can do that. Okay, SD is very useful measure for scatter of the observations. Now coefficient variation is nothing but the percentage of the SD mean. Okay, so it is simple. Coefficient of variation, if you have to check the coefficient variation, simple formula. I mean, see, you don't need to remember these formulas, guys, frankly, if I tell you, because everything is being done by the software. One click, so SPSS, one click, everything will be done. You don't have to do anything. Okay, you don't have to do anything. So SD divided by mean into 100, standard deviation, it will come. Main thing here is standard error of mean. Okay, sometimes your standard deviation also is same, so you need to dive more, you need to dive deep. Okay, you need to dive deep to find out that difference. You need to dive deep to find out the difference, and you have to go to the SEM. Okay, SEM is nothing but the extended variability of mean, extended measure of variability of the mean, and it is the precision. Okay, precision different, precise different. I mean the accuracy. If you want accuracy, don't go for SD, go for SEM. Okay, SEM is always accurate. SEM is always less than, always less than SD. Lot far less than SD, almost 10% of the SD only. Okay, but it will show the precision. It will give you the precise difference. So how to count? How to calculate? SEM is equal to SD divided by under root n. Like whatever is SD 4.08 under root 7 is your SEM. Okay, under root 7 is your SEM, right? So it's always like we always write mean plus minus SD usually, right? It's not necessary. You can just write mean plus minus SEM. This shows more precision. This shows more precision. This shows more precision. Okay, guys. So that's about that's all about the standard. I mean the central tendencies and all. Okay. Now, I mean you understood these things, and you know quartiles. There are 4 quartiles. One 25%, 25%, 25%. So quartiles are also being used. Okay. So now you understood the central tendency, you understood the data types, right? Now we will go to one very specific part of this, how to select the test. Okay. Before that, I want to tell you the SPSS. Okay. Before that, I want to tell you the SPSS. Once you are well from the SPSS, you will download it. I'll show you my SPSS also. I'm using the 22 version, but let me tell you, let me take you through the SPSS. Okay, you want a 5 minutes break? There is only next 40 minutes I'll take. Okay, you want a 5 minutes break or you want me to continue, guys? Tell me. I'm fine, anything. Yes, guys, do you want to continue or you want me to take a break? 5 minutes break. Okay, take the 5 minutes break and we'll join after 5 minutes exactly. Yeah. Okay, guys, I'm back. Let's start. Let's not delay because it's going to be huge class, you know, literally. Okay, so let's go back. So now let me tell you about the SPSS a bit. Okay, bit about the SPSS, how it works, what exactly is this, and you know, then I'll tell you how to select the test. By the way, anyways, tomorrow Dr. Siddesh will be telling about the tests, but let me tell you about the tests. Okay, let me tell you about the tests and SPSS. Let me show you first thing. Okay, so okay. Yeah, this is the slide. Just the basic information about SPSS. I'll just give you the basic information I have updated today. Okay, what is SPSS? So SPSS is the statistical package for the social sciences, which was released in 1968. Okay, this software was released in 1968 by two people, Norman H. Nye and Huldai Hull Norman. Okay, so they were the political science postgraduate at Stanford University. Okay, in 68 they came up with the SPSS with the original name SPSS, Statistical Package for Social Sciences, in 1968. And these two students were working, studying at Stanford University. How they come up with? If you remember, you maybe you don't know, guys, but I love reading history. So that time there was a financial crisis in US. Okay, kind of financial crisis, financial loot, they say it. Okay, financial loot means everyone was just taking the people, like the employees, at any rate. They were selling there was no fixed things. Okay, there was no fixed rates, there was no fixed salaries, there was nothing. So that was called as this financial loot, or some specific term was there at that era. Okay, so these people have come up with this idea of developing. I am not sure, baby boomer or something, but yeah, maybe. That was the time, So they came up with this idea of statistical analysis where they can help everyone in US to minimize that kind of things. So everyone will get the average, everyone will get the significance difference between the different the companies, different employment rate, different employees, salaries, their wages, everything, and that's how they came up with this. But still, again, they did not use it for the finance purpose. They used it first for the political gain. Okay, they used it for the political analysis, like how much vote from this area, how much votes from this area, how much vote this party will get, how much vote this party will get. They used it for the political science, as these students were from the political science only. Okay, and then they use for the finance first time. Okay, and this is one of the top softwares. I mean, right now for the researchers, for the universities, everyone use SPSS in the universities and academics. Academics, they use SPSS only. This is the software which is widely used for the statistical analysis. Okay, so Neo served the CEO of the company till 1992 and continued as the chairman of board till 2008. But let's not go to this. Now the thing is, in 2010, IBM company has purchased the SPSS entirely. They have acquired the SPSS, and now it is an SPSS, which is an IBM company product. Okay, if you know IBM company, can you tell me one more product? IBM company have all type of softwares for the healthcare analysis, data analytics, multiple type of things. Can someone tell me one more example from the IBM company, what you are using or you know that? Yes, guys. Micromedex, perfectly. Micromedex is also one of the IBM company software. Micromedex. Okay. Yes, Micromedex is also one of the company IBM company product, and you all know Micromedex is used for the drug interactions and drug interactions and all, right? Drug information database. So what is SPSS? That time it was SPSS, like a statistical package for the social services. Now once this IBM has purchased it, they have changed the name of SPSS. This is still SPSS, but now the full form of SPSS is Statistical Product and Service Solutions. If someone asks you what is the full form of SPSS, that is Statistical Product and Service Solutions. Between 2009 and 10, I mean, this was when when this merger of SPSS into IBM was going on. That time it was changed for some time, like Predictive Analytical Software POS, and now, but again it has turned to SPSS. You don't have to worry about. So latest version of SPSS is 29. Okay, latest version of SPSS is 29. I am still using 22 because that is the university version. Okay, that university has given to us 10 years back. I'm still using that. Okay, and it is very costly, guys, very, very costly, right? But I'll tell you how to download it for free and how you can even purchase the things. Okay, this is right now 29th version. This was released on September 13th, 2022. Okay, and operating system Windows and only Mac OS. That's why I told you no iPad, no tablets, no mobiles. It doesn't work in mobiles and tablets and iPads. Okay, so platform is Java. Now the price is, usually the basic subscription price is 99 USD per month. Basic price of the monthly subscription is 99 USD for the students. Base 26 version is 1290 USD per year if you are taking for per year. Okay, then the statistical standard. There are three versions. One is basic, one is standard, one is professional. Standard version costs around 2.5 lakh rupees per year. 2.5 lakh rupees per year. And the statistical professional comes in around 6 lakh rupees per year. Okay, including taxes, it comes around 6 to 8 lakhs per year for the university's professional version. Okay, so it is not at all easy. It is a paid version. Okay, but I'll tell you how you can use the free software for 1 month trial version, and then you can purchase it from the verified vendors of IBM. Those give it in the very cheaper rates. Okay, if you want to use it. So use of SPSS, I told you, it helps in data extraction, it helps in data analysis and all everything. Now let me take you to the website. Let me take you to the website so you can understand how to purchase, how to download, and then you guys download it right away. Okay, go work it with me. Okay, guys, work with me. So I can tell you in last 10 minutes, I can tell you whatever I told in the previous slides, like how to data interconversion and all, how to, I'll show you the SPSS book. I'll show you the SPSS front end and back end. I'll show you the SPSS window, and then we can work on together. Okay, for 10-15 minutes. So next 10 minutes, you have 10-15 minutes, you have time to download it with me. I mean, I have already downloaded. I will not download, but I'll tell you the entire process. Okay, then if you have any issues, please tell me, we will resolve it together. So are you on with the laptops, guys? Are you on with the laptops? Yes, please write in your comments, guys, come on. Great. Okay. Yes, yes, yes. Perfectly fine. Perfectly fine. So let me go to that. Let me go to that. Okay. Okay, let me open my Google Chrome. Oh, let me share this. Okay, I did not share it. Okay, so this is Google Chrome, you all know, right? So if I go to, if I write IBM SPSS, nothing, IBM SPSS statistics, just I'll click on this. And the first thing comes is IBM statistics 30 days free version. Okay, you can go to anywhere. You can go to IBM statistics also. IBM website, you can go and you can just click on this IBM SPSS statistics. You will get to the website. Okay, everyone, please follow me. Just write SPSS IBM and you will go to the this website ibm.com. In the products SPSS statistics. Okay, SPSS statistics. This is the website. I'm just copying, pasting. If you are not finding out, I'm just copying and pasting in the chat box. So you can just try it from here, guys, please. Sorry. Yeah. So I kept it in the chat box of this Zoom meeting chat box. Please check and please click on this and go for it, please, guys. Okay, please go for it. Done. Okay. So now look at this. So this is IBM software. Okay, IBM SPCs, additions and all are there. I'll come to that later. But look at this. Try SPSS statistics for free. There is one more. One is buy now. One is try SPSS statistics for free. Click on the try SPSS for free. Okay. Try SPSS for free. Okay, try SPSS for free. Now you will see that there is the thing comes create an IBM ID. Okay, guys, one more thing. If you have created your email ID, if you have created your IBM ID before with any email ID, that will not work right now. Okay, that will not work right now. You have to create it with the new login ID, new email ID, and one email ID will work only once for the 30 days trial in 1 year. Okay, if you are using the clinical, you are using the 30 days trial, your one email ID will work only once in a year. Okay, once in a year, right? And once you download this software, you will get it for 30 days free of cost. Okay, and after 30 days, if you try even with another email ID, it will not be downloaded in your computer. Even if you format the computer, if you format the, if you just delete the software, if you just delete the software entirely from your computer, then also you will not be able to download the trial version because it leaves the spyware in your computer. Okay, it leaves the spyware in your computer. Whenever you try to download the version, download the trial version again with the a new email ID, it detects and it will not install that at all. Okay, so if you want to try the trial version all again, you have to completely format the computer. Okay, for one, in the 1 year you can just try only once, right? But now we are working on it, we have to work on it, so go for it. Email ID, first name, last name, password, put it, guys. Password, you just select your password. Indian origin, Karnataka, wherever your state is. Phone number, are you a student? Yes. Are you a student? Yes. Then go next, verify your email ID. They will send one email to your email ID immediately. You have to verify it and then you will get the 64-bit or 32-bit software. Okay, you will get 34 32-bit or 64-bit. So always go for the 64-bit software. That software is quite big. Okay, software is quite big, it will be around 900 MB to 1 GB. Okay, so please make the IBM ID and download it, guys. Download it. Okay, please download it now. I'm just keeping myself silent for 5 minutes. Okay, you just download it, please. Download it. Okay, If any questions, please write speak. I'll help you. I'm here. Anyone who has done or stuck somewhere? Any questions, guys, here? If you're sticking somewhere, if you are having any trouble anywhere, please let me know. I'm here only waiting for you.
Sir, I got option to download. Hello,
Okay,
sir.
options. In the options to download, there are two things. One is 32-bit, one is 62-bit, 64-bit. Download the 64-bit, please.
Yes, sir. Download for Windows 64-bit.
Yes, please. Yes, please. Yes, anyone else who has trouble? Let me see the messages. Downloading. I got the option to download. Okay. Yeah. Please, please. I'm waiting, guys. I'm waiting.
So I already downloaded it, but like in my this thing, it's saying license not valid, launch license was
License not valid.
set
Did you have the
license and
SPSS
restart and
software?
exit.
Did you have the software before in your computer, Dr. Devas?
But like I downloaded it yesterday or day before, and then like I don't know, it's just popped in like that after that.
Really?
Like
आइयो
2 दिन ही हुआ है डाउनलोड किए हुए.
कोई बात नहीं. इट्स
Yes sir.
ओके. यू ट्राई अगेन. दिवस
Yes sir,
दोबारा
because
ट्राई
you
करो. दिवस दोबारा ट्राई करो
नहीं
आप.
मैं किया हुआ, आज अभी भी ट्राई किया, डाउनलोड करके मैं पूरा रजिस्ट्री भी रिमूव करके ट्राई किया, फिर भी नहीं हुआ.
No, it won't work then. You must be having. No, you download the software and try installing. You keep it like that. No worries. I'll tell you how to install. Okay. You just download it and then we'll try. Okay, I cannot show you in my computer how to install it because I've already installed, and if I uninstall the institute version, then I'll not get it again. But I'll show you one format. Wait, guys, I have everything for you here. One sec. I'll show you it. I'll just open this Word file so you can immediately understand. Okay. Yes, how many have you downloaded, guys? How many of you have downloaded the software? Okay, let me share this. You read this and yeah, no worries, no worries. You download. I'm here, guys. I'm waiting for you. Okay, don't worry. Okay, so this is the see. This
Excuse
is
me,
yes, Jyotsna. Please tell me.
I just download my site and it's showing your session has expired.
No, no, no. You just did you validate your ID, email ID?
Sir?
Did you verify? Did you verify your email ID?
Ah, yeah, sir. I just verified and it sent me a code and I just entered it and your section has been entered. Expired is coming, sir.
No, no. Try again. Then it's okay. You try again. It's fine. See. So guys, see, this is simple. Sign up as the IBM ID, go to the product services, download, okay, save the file, click save file if, click the save, okay. And then once Microsoft Window machines navigate the save file location, right click on the file and select run as administrator. Okay, once it is downloaded, select Run as Administrator from the menu. On the Mac OS, you must double click to install, but in the Windows, normal Windows, you just have to run as administrator. Okay, follow the installation steps, all the steps, and that you will be done with that. Okay, you will be done with that. Yes, install, guys. Simple. Yes, Astosh. Yes, guys. Okay, sir, it says unverified download, but I verified already. No, no, it's okay. If it is downloaded, go to the file. Okay, whether it is unverified or verified, go to the file, please. My email ID is not accepting. Rama, I'm not sure why it is not accepting, madam. Sir, whatever. Why it is not accepting? Please try again. Why it is not accepting? Did you verify it? Please verify it because it takes some time in the verification. And once the verification is done, you will definitely get it. Try another email ID. It's okay. I mean, so see, you can try another email ID also. Okay, because email ID is just needed for the verification. Okay, please try with another email ID. Create another email ID. It's okay. It will take just 2-3 minutes, 4 minutes in Gmail. Create another email ID and please try with another email ID if it's not accepting. Okay, who has downloaded, guys? Who has downloaded and who has run the administrator and as administrator, who has installed the software? Please tell me who has installed the software. Please raise your hands. Who is struggling right now? Okay, I believe like no one has installed right now. Okay, it takes time because it's almost 1 GB. Yes, guys.
Sir,
Yes, guys.
installed.
Installed. Perfect. 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 Installed, guys. Please raise your hands. Whoever is installed. I already have it installed, sir. Okay. Sugasta. Okay. Nice. Someone else, please, guys. I want everyone to install it. Okay. So this is the workshop where I want everyone to participate.
Sir, I clicked on run as administrator.
Okay. It will be showing some, some more commands.
Task.
Please keep yes. Select the language as English. There will be language, and then you go ahead, please.
Yes, sir.
Any other guys? Are you trying? Are you trying? Let me ask by names. Installed. Revati installed. Perfect. Okay. Aishwarya, Ahmedullah, Achal, Anusri, Anirudh, Ardra, Divya Chaudhary, Divash, Sadia Rauf, Dr. Sadia, Gagandeep, Harita, Gomati, Jasmeet, Jyotsna, Nidhi, Prabhakaran. Please, guys, Premalata, Prashad, Rama. Please, guys, Susmita, Vijaya, Venkatgiri, Kiranmai, ma'am. So, please, guys, tell me if you downloaded. Try to run same error. Okay, downloading is still. Oh, it's a big software actually, 900 MB, so it takes time. Okay, no worries. You take 2 more minutes, 3 more minutes. We'll take 4 more minutes and 220. I will show you the SPSS from my side. Okay, guys, no worries. We take 4 more minutes because the 4 minutes, I think some internet issues are there for because you need high speed internet to download. Guys, don't worry. Okay, don't worry. If it is not downloading, please try now. First of all, if it's not downloading, please do it today, and then you can learn it tomorrow, because tomorrow again we'll tell you about these things and you will be learning all the things. Okay. Okay, no worries. Let it download. Let's try again. Maybe try with another email idea. Run as administrator. If it's MacBook, then go to the installer and then install it. If it is normal computer, then please try run as administrator. Okay, and then it will be run. The software will be run. Okay, guys. Yes, please. Any questions? Are you downloading? Okay, let it be. Let's take rest for 2 minutes. Let it download.
sir.
Yes, Sohana, please tell me.
Sir, now I have to activate your subscription or trial. So I have to click login with IBM ID.
Yes, log in with IBM ID.
Yes, sir. Sir, ID means the password or like the email.
No, there will be an IBM ID. There will be an IBM ID which you have created there in the website. That same ID you keep there, and you keep your password also, same thing.
Okay.
Whatever you have done in the website, you kept one website, one password, and one IBM ID was generated, which will be in your email. Keep that.
Sir.
Okay.
Sure.
Guys, it is 2021. How many of you have downloaded and installed? Is it installing still? Okay, by the time, let me open my SPSS. Okay. And don't worry, I'll share these slides also with you, handouts of the slides. Okay, don't worry. I'll share the handouts of these slides also with you. So it will be useful for you along with the recordings. I'll share all the data. Okay, don't worry. This is not something like I cannot share. I will share with you so you can easily understand the things. It will take some time. It's okay. Okay, so guys, no worries. You download, you keep it with you. Okay, what I'll do is tomorrow the class is at 11 o'clock, right? Tomorrow the class is at 11 o'clock. What I'll do is let's join at 10:30. Let's join at 10:30 for 20 minutes, and we will clarify all the issues whatever you are facing again. Please try, if it is not downloading, please try with new email ID. And then in that 20 minutes I will show you the SPSS also, because I don't want you to just see my SPSS. I want you to practice it. I want you to see it perfectly and try it with try it in your computer. Okay, so take your time, no worries, we have a lot of time. Take your time, download it, install it, and whoever is not getting installed, please message me in the group. We will discuss in the group. Please send the screenshots, whatever it is saying. We will try to resolve it, and we will resolve all the issues again tomorrow 10:30 morning. And I'll show you the statistics before you jump into the proper analysis part with Dr. Siddesh. After that, Dr. Siddesh will take care of that. And I'll tell the measures of central tendency all and the data transformation, everything. He will only tell you, don't worry. Okay, but I'll come and I'll resolve, or I'll see if Dr. Siddesh only, I'll tell Dr. Siddesh only can take care of the, further things like installation also. He will take half an hour extra, no problem. I'll tell him. Okay, you take your time, no worries. It will take time, I remember, because it is 1 GB software, right? So we'll wind up here, guys. We'll wind up here today. Okay, but I believe that we should meet at 10:30 for some more time. So I'll tell you what are the tests and what to use and how to use. I'll show you in the SPSS also. So tomorrow we'll meet at 10:30. Okay, right? Okay, guys.
Okay, sir. Yes, sir.
Yes, that would be great. Okay, yeah. So you download, and if anything, any trouble is coming, please message in the group. Please send the screenshots in the group. Okay. Take care, guys. Have a good night. Please do it today only, but don't. Good night means does not mean that you forget it to download. Download and install today. I'll see 10:30 for 20-25 minutes, 30 minutes, and then Dr. Siddesh will take care of that. Okay. See you guys. Bye bye. Take care, guys. Good night. Bye bye. Thank you. Thank you, everyone.